All right, hey guys, I'm here today to tell you how to perform a thermal mod on the Unifi switch line from Ubiquiti, specifically the 8-port switches, not the rack mount models. So that would be the US-8, US-8 60W, and US-8 150W models. So before we get into it, just a couple of comments or questions I'm sure that are going to come up. First of all, why would you want to do this mod? And the answer is pretty simple. It's to get the temperatures down. Electronics and temperatures, high temperatures don't go that well together. And so bringing down temperature is always a good thing. Now, the follow-up question to that is, don't these switches have a spec, and aren't they running in spec? And the answer to that is a little more complicated. Basically, yes, usually they'll be running in spec, but there's a couple of caveats with that. The first is that just because there's a spec doesn't mean that there aren't different expectations or failure rates at higher temperatures versus lower temperatures. If you lower the temperature, it's basically always going to be better. And these switches, being passively cooled, tend to run at the very higher end of what you would probably consider to be a nice temperature range. So just because something in spec doesn't mean that there aren't there aren't better ways to do things. I think the second point would just be that sometimes you need to run these switches in places that aren't entirely up to the standards of the documentation or instructions given to you regarding the switch. For example, I need to run these switches in one pretty enclosed space without a lot of ventilation, and I also have another one in a data closet, which is pretty hot by definition, certainly above normal ambient temperatures, and stacked on top of other equipment or around other equipment. These instructions tell you to run these switches in, well-ventilated spaces, at least a few inches apart from any other walls or anything that might block the ventilation holes, and that's usually not that practical. You don't always want to be able to do that, or you don't have space to just, space everything out. So by performing something like a mod like this, you basically buy yourself a lot of extra headroom thermally and reduce the chances of failure in cases where, just because something's running, you don't have the luxury of running something according to their instructions. Anyway, the reason we're doing this mod is that I had performed the mod actually on the US-8 150W, which I will provide a link to the description of in much more detail, so you can look at that. One of the reasons to do this mod is simply that it's a very kind of permanent mod. It doesn't require anything external, doesn't require fans, and it basically is kind of makes the switch just better as long as it meets your requirements, because it's more likely to last longer. So with that said, there obviously are alternatives to performing this particular mod, which involves interfacing the CPU inside to the outer case, top case, and the reasons not to do it, for the sake of being intellectually honest, first of all, it basically makes the top case hotter. So when the top case is hotter, it can become much more uncomfortable to the touch, and you may not find that desirable. I think for most people that just put these in a closet or something somewhere, maybe next to their desk, they're not going to be sitting there putting their hands on it all the time, but it is something to consider, and it's probably what the designers were going for, was to have the case intentionally be a little bit cooler to the touch at the expense of higher internal temperatures. Now, the second reason you would probably not want to do this is, also involves the top case being hotter, but it's simply if you have other electronics stacked on top of it or other things. So, in that case, maybe you just want to reposition things, or don't do the mod. It's fine. These switches are designed in a certain way, and you can just decide what you are comfortable with when it comes to handling the switch. But there have been a lot of complaints about the temperatures of these switches, and so here's a way to get them down. Now, I think the final point to make here is that, how much does this mod help? In my experience on the US-8 150W, it brought down the temperatures about 7 degrees, as measured by the internal sensor. So that's actually quite significant for something that requires no active cooling or really any sort of additional maintenance. So it's fantastic, and it certainly makes a big difference. So yeah, and I think the final point to add here is in terms of why do this mod is it is a very kind of permanent no-frills mod, and it doesn't require you to do any additional supply any additional power, take a fan and put it on top of it. With that said, certainly taking a fan and blowing it through the ventilation holes is extremely effective. But this is for somebody that doesn't want to have to constantly worry about where they're putting their switch or where they're putting a fan next to it. This really does just make the switch much more effective at dissipating its own heat. So that's a good thing to do. And so it's nice to be able to do that in just a couple minutes and go about with the rest of your life. So with that said, we are going to show you in the next series of clips how to open the switch, add the thermal pads, close it back up, and then I'll show you the thermal results via a FLIR-1 infrared camera. So that should be fun. All right, so here we have the switch, Unifi Switch 8 by itself. We're ready to mod it. It's a very, very simple thing to do. First thing to do is open up the back here, take the 2 screws here and here out with a normal Phillips head screwdriver. Then just slide the front out and pull it off. So I'll show you how to do that. So I've done the 2 screws on the back. And now you just pull the front off and pop it off. And again, be careful, there is this little serial header here. You can control all the little lights in the front, I think. Yep, these little lights, indicator lights. So here it is, here's the switch. So now what we want to do is take some thermal pads. This is very similar to the mod I did for the US-8 150W. But simply take these thermal pads here, stack them up, put them on top, and interface to the top case with the pads. So we're going to do that. And just so you know, see if I can find my ruler here. Here it is. This heatsink is about 60 millimeters ish, maybe 55-ish. In both dimensions. So I have determined from previous experience that about 3 to 4 millimeters thickness of pads is about what we want. In this case, I just happen to have 100 millimeter by 100 millimeter pads lying around. So I'm going to stack them up and just put them on here. But if you were doing this from the get-go, you'd probably just order a 4 millimeter thick pad and cut it to size. The other thing I would say that you'd want to do here is maybe just put these thermal pads up near the front so that when you slide the case on, they kind of smush themselves and center them. Otherwise, when you put it back on, it tends to slide the thermal pads back and off a little bit. All right, so we're gonna try and do that right now. All right, so now we've got the thermal pads on. I've stacked 4, so that's 4 millimeters thick. I think I could get away with 3, but we're just gonna do 4 to be safe. It does make the top case bulge ever so slightly, but not a problem, and that means you're getting good contact with the top case, obviously. One other thing I did here was I also moved the wires here for the top so that they would be more out of the way of the heatsink. Before they were kind of going like this, and it made it seem like it was going to get under the pads there, so I moved these out of the way. So here we go. Okay, I'll put them on now. All right, let's put back together. Now we are going to put it back in place and see how it does. Again, we're not going to have much telemetry in terms of the actual switch itself, the temperatures inside, but just seeing the temperature on the outside get hotter means the insides are cooler as a result. And I'll attach some photos of another switch where I was able to measure the bottom of the case and see that it was cooler. And that will provide additional evidence of things working the way they're supposed to. All right, so here we've got the US-8 Unifi switch that I'm going to perform a very simple thermal mod to. And here is the switch before the mod. And as you can see, there's a nice hot spot right above the ventilation where those vents are pointing out. It's about 108 to 110 degrees Fahrenheit. And the top case itself does not have that much of a hot spot. It's really just kind of associated with where the air is coming out. Again, passively cooled. But the hot spot here, let's say the hottest spot is probably the top of the case here, where the air is coming out, and that's about 103 degrees or so. All right, so let's see what happens after the mod. You know, what happens is when we connect the heatsink to the top case, the case will get hotter. So that will help dissipate a lot more of the heat. Right. Okay, so here we're looking at the US-8 switch after we've performed the thermal mod. It's important to note that this thermal image is auto-ranging, meaning it doesn't directly compare. It kind of gives you more of a relative view of the thermals, but the measurement of the temperature on the crosshair does compare. So, you know, for reference, before the thermal mod, we were seeing temperatures of around maybe 100 to 103 on the top case, kind of spread evenly all across it because, you know, there is no thermal interface to the top case from the CPU in the normal version of the switch. And at the top where the vents are, we were seeing a hot spot. We were seeing it at about much brighter view of the thermals, and it was about 111. So here we see a much different view with the thermal pads interfacing the CPU to the top case, getting a hot spot of around 109. Yeah, 109 versus 103. So fairly significant. Not as much as you would expect, honestly, considering, and I think that's simply because the system is cooling better as a result. You can see that actually what was normally here, there was a big, bright, hot area above the ventilation holes, and that is gone, actually. Not really there anymore, and you can see the air kind of floating out is, you know, maybe around 100 and 106, 108 tops. So, yeah, I mean, unfortunately, unlike the more expensive switches like the US-8 150W, we don't get a view of, we don't get a sensor on the inside that tells us what the temperature is, but we can tell that the interface to the top case is definitely working because it's making the top hotter. And I will show photos later of a switch on the top and bottom and how the thermal mod affects it positively. But this is working. So very good. All right, well, there you have it, guys. That's how you do the mod. Um, I have, as I promised, some additional photos just of the other mod that I did for the US-8 150, and also some FLIR photos of a different US-8 switch, with a little more documentation. So why don't we start with the US-8 switch photos here. So here we go. Here's one. Here's the other. Yeah, so here's a before and after. So this is a switch where I was able to take a view of the bottom, and as you can see, there's a little hot spot where the CPU lands. And this is before the mod at about 112 degrees Fahrenheit, and that dropped to around 107 after the mod was performed. So again, maybe I didn't make this clear earlier in the video, but the CPU is thermally interfaced to the bottom of the case. So what that means is by interfacing the CPU to the top of the case as well, you reduce the temperatures where it was before. So this dropped this temperature by about 5 degrees. So that's good. That's a good sign. Also important to note the implications of the CPU by default being interfaced to the bottom. Airflow on the bottom is typically poor because it's sitting on something. So I've noticed a lot of people, in order to cool these things, try to blow a fan across the top. They put heat sinks on the top. Not very effective, actually. Better than nothing, certainly. So don't get me wrong, but you'd be better off actually turning the switch upside down or somehow facing it out from the wall. Anything you can do to get that bottom extra airflow. But again, blowing a fan is still very effective. Blowing it through the ventilation holes, super effective. So if you want to go that route, by all means, it's still a good option. Next thing I'm going to show you, these photos are all on the link that I gave, that I'm going to be giving in the description. But here are some photos of the US-8 150W. It's kind of a before and after. Basically the same heatsink, possibly the same CPU. Just a bigger case with a power supply integrated. So you can see here, same thing I did with thermal pads. Again, I would recommend just placing them a little bit closer to the front before sliding the case on, so that the pads kind of end up where you want them to be. But other than that, very, very similar mod. And see if I got the right photo here. Yeah, here is the photo right here of how the CPU is connected to the bottom of the case. So same advice applies. Just be aware of where the heat is going. Okay, well I hope that was all useful to you guys. It's actually, again, very simple mod, but there's some background behind it. So all that context I hope was useful. Yeah, okay, well, hopefully a few of you will get your temperatures down. You'll find a way to make yourselves comfortable with the temperature range that these things do sit in. They are passively cooled, so they get very, very hot, and this is a good way to drop the temperatures. Thanks again.